Welcome to your third set of videos. This lesson is 1.4 and we're going to talk about functional behavior, we're going to talk about critical points, and we're going to do something called the average rate of change. First, what I'd like you to do is to just copy these lines here on this graph, and let's think about where the function is increasing, decreasing, or remaining constant. And I'd like you to read the graph from the left to the right, just like you would normally read a book. And as you're reading, and think about writing the graph. So if I'm writing this graph, I'm going up, and so I am increasing. And let's label that one f of x. So that one is function f of x. And if I am, let's grab another color. If I'm going down, if I'm writing this, coming down, that one is decreasing. Let's label that one G. And if, obviously, like flat line, all right, just horizontal line, that one is a constant. Let's label that one H. Now, it's a little confusing to people because I told you that this green line was increasing, that function was increasing, but it's going, the arrow's going down. You're looking at the function values. The function values are increasing each time. If I were to take an x here, that x value, and then another x value, the subsequent x values, you would see the first one was less than the second, which means that that function is increasing. Okay? If I were to look at the decreasing functions, if I were to take that point and that x, the function at those 2 points, that function between this one and the this is the lesser one, this because they're negative, and between each one it's increasing, this one is greater than that one, then the function itself is decreasing. And the constant is just a horizontal value, same value. So if you'll think about it as if you're writing them, it's very easy to look at the picture and just determine you're writing it up, you're going up, so I must be increasing, or you're decreasing and coming down. I'd like to do an example. So if you would please copy, you can pause the video if you want, go ahead and copy this crazy little picture here, but we're going to talk about where it's increasing and where it's decreasing and where it's constant. Alright, so let's look, I'm going to keep with my same color scheme here, increasing. I'm going to pretend I'm going from left to right, I'm going to pretend I'm writing this. So here I go, I'm coming in, I'm increasing, I'm going to be green here. And then all of a sudden I hit the peak and then I'm going to go down. So I'm decreasing, okay, to that point. Oh, look, I'm increasing again. I'm going back up. Then it's constant for a little while until what? It doesn't drop. It goes back up. It's increasing again. So let's identify these intervals where this is happening. Increasing. Started increasing over here. So that was from negative infinity all the way increased up to the x value of negative 2. Okay. It's also increasing on the interval from 0 up to x is 2. And it increases here from 4 to infinity. Decreased. It went down here from when x was at negative 2 to 0. And it was constant from the interval 2 to 4. Now there are a couple things I just want to highlight about giving me this information and analyzing the function this way. All right, so let's just make a little notes here. All right, I want you to always use parentheses. Okay, you don't use the brackets. Because at that point, At that point, when x is -2, at that point you are neither increasing nor decreasing. So it never is going to equal at that point. You're giving me intervals upon which it is increasing or decreasing. You're not talking about at that point. So that's why we're not going to use brackets. Right? We always use parentheses. And also to just help you remember, you're going to always give x values of the function for the intervals. You're looking to see what the function is doing, so you're looking at the y values. Are the y values here increasing? Yes. But you're going to tell me the interval on the x values. You're telling me the interval upon which it is increasing or decreasing or remaining constant. The next thing I'd like to talk about are the critical points within a function. Critical points are points where if you draw a tangent line to the graph, it's going to be either a horizontal or a vertical tangent line. Another way to think of it is it's where the function is going to change direction. You understand what these are. You've used these before. But you're basically talking about either a maximum, a minimum, or a point of inflection. Okay? Now, when you have a maximum, you can have what's called an absolute maximum or you can have a relative maximum. What that means is if your function is such that it's going up and down and up and down and it has one peak, but then it has another peak that's a lot higher, okay, the highest one would probably be the absolute max. Okay? Or a relative would just be a little bit, right? It would just be coming up a little bit. And so that would also hold true for the minimum. You can have a valley and it looks like it's coming down, or you can have the lowest point that that exists within that function. So I'm going to let you pause the video if you want to, kind of sketch out this crazy little curve. And I already see a mistake in my curve, so I'm going to erase it. And I'm going to stop it right there. All right. And now let's talk about the maximum. When you have a max, and it's pretty easy to tell, you can probably look at this right now. I think I need new pens. And you can determine where the maximums are. Okay? A maximum is going to happen when you were increasing and then now you're decreasing. So you were increasing and then you decrease. So for example, this would be a max, wouldn't it? And this would be a max. Now one of them is a relative max and one of them is an absolute max. The relative one would be the lower one, and the absolute max is the higher one. It's not going to get any higher. Now, the reason I had to erase this is because that end of the graph, I had an arrow there, and it was going on forever and ever and ever, which meant there was going to be another maximum somewhere, and that was not going to be an absolute max either. But if I cut off my graph and I stopped it, then that is now an absolute max. Okay? And as I see my graph, I need to do the exact same thing for the minimum. So I'm going to just magically change the graph. Ta-da! All right, so now let's look at the minimums. A minimum point would be you were decreasing, right? If you're minimum, so you were decreasing in your graph, and now the function is increasing. It's going back up. So this point right there, let's label some of these. This one right here would be a minimum. This would be a minimum. Okay. This would be a relative minimum. This would be an absolute minimum. Now the point of inflection is this point right here, because it's a point where the graph bends, but it doesn't change, it's increasing or decreasing. So let's write that out a little bit. So it's a point where the graph bends up or down, but it remains increasing or decreasing. Okay, so this right here would be a point of inflection. And so what we're going to do is we're going to, obviously you can predict maximum and minimums if you are, this has a lot of applications in a lot of our word problems. You've learned already how to calculate these on the calculator, use that little trace feature. The definition, I told you it was a point at which a tangent line was horizontal or vertical. Let's go back and look at those. See, so this has a horizontal tangent line that goes through those, and that's why that point would be a relative max or a min. It's a critical point. This one has, this tangent line would be going like right there. So they are vertical or horizontal. Now let's talk about average rate of change. Okay, here we go. Think of some of the things you've learned so far. You can identify a function with its domain, its range, its what the end behavior is doing. Is it continuous? Is it discontinuous? And how so? Does it have any critical points? Where is it increasing? Where is it decreasing? Something else you would like to know sometimes is, what is the average rate of change of this function? How is it changing from point to point and along the path of the function? Well, you're used to using linear functions and finding the average rate of change, which is a fancy way of saying the slope, right? How is that changing from point to point? And if it's a linear function, you're used to just calculating m equals, remember it was y2 minus y1 over x2 minus x1, and that was the slope. It's constant. What else did we call it? We called it rise over run. All of those things. If we had a point here, let's call it x1. If we had a point here that was x2, it correlated to that y1, right, and this y2. And we could calculate the different change between those. Okay? When you come back in the second video, I'd like to talk about how am I going to find the average rate of change of this curve of a nonlinear function. And we'll do this in the second video. I'll see you then.